aren't standardized. They're not as rigorously controlled as the electrical trade, for example. If you call an electrician to your house to do some work on the wiring, how do you know that they're an electrician who's not going to burn your house down? Well, they've gone through an apprenticeship, they follow standards, they've got guidelines, they make sure that, they know their job and they're licensed before they go out in the field and start playing with the 240-volt wires in your house. What kind of guarantee do you have that your cloud provider is of the same standard? We currently don't in a lot of aspects. We do have security assessments like IRAP in Australia, FedRAMP in the US. So there are things which are being pieced together, but the technology of cloud, it's decades old. It's not hundreds of years old. We're still formulating a lot of the structures and the practices which go around it, and it evolves rapidly. So having organizations like NIST, and we'll hear later about the Cloud Native Computing Foundation, to guide that process and shepherd it collectively is really important to organizations like government who will rely on cloud technologies to deliver services to their customers and end users. So end characteristics, we saw that, essential characteristics. We saw that slide which gave a really nice text discussion about what makes a cloud. They've got some ones further down that PDF. And the reason that I'm relying on the PDF is because I'm looking to the authority of a globally accepted standard so that we remove the ambiguity. We've got our colleague from Google presenting later. We've also got hyperscale cloud providers from Microsoft, AWS, Tencent have a cloud, Alibaba cloud in China. All of these corporate organizations may have a different take on what they want to say cloud is. That's the commercial world. When we have standards in place, we remove that ambiguity. So it's important to have bodies which recognize what a cloud provider is, what a cloud service is, so that we're all talking about the same thing. On-demand self-service. That basically means if I want a computer in the cloud, I can get one and I can ask for that myself. Very important. Broad network access. I can get to that computer from almost anywhere. If I've got a server sitting in my basement and I can't access it, it's of no value to me. So part of cloud is broader network access. First type of network, internet. Okay, so you can jump on your web browser and you can open up Chrome and you can go to a cloud address and you can say, okay, I'm going to log into the Oracle cloud or the AWS cloud and I'm going to bring up a compute instance, and that compute instance can serve web pages across the internet. How does the federal government connect their networks together? Icon. I'm glad Google came today. When in doubt, Google the answer. So Icon is a dark fiber network, and that's like a private network. If you want to get to the cloud via Icon, you're going to need to have a termination point. But this is what we mean by broad network access, so not just the internet. To have telephony companies like Verizon, internet exchanges like Equinix and Megaport, the people who connect the large data centers of the world together, also providing a secure, discrete channel, private network communications into the cloud. That's another way of broad network access. Essential for security, essential for having a service level agreement. You know how much bandwidth you've got going into and out of your cloud. Resource pooling, very important. That was the appeal of the first model. If you need extra resources, you can grab them from a pool. When you don't need those resources, you can give them back. And that gave rise to rapid elasticity. And that means that if Black Friday sales, all of a sudden there's a million shoppers who are looking for bargains. We need more compute resources. I need those resources now. What's the alternative in the old world, the on-premises world, if you needed another server? What's your lead time looking like? Anyone from procurement in the room? Weeks, months? What was it like during the pandemic? 6 months to get a server? In some cases, yes, because the supply chain was disrupted by COVID locking down half the world, or more than half the world. The rapid elasticity of cloud providers really did a lot to save a lot of economies around the world, because they had the idle compute resources sitting there as their buffer. And when people got sent home and they needed to use Citrix to log on, a lot of organizations just went to the cloud. They expanded their capacity, they drew from that pool of resources, and it was the cloud provider's problem to make sure they had enough available. Right? But they did that in a matter of days to weeks for some departments. For some corporations, which were a lot more agile, they did it in a matter of hours because they already had that cloud practice in place. We need more resources. Bang, there it is. And the last one is the most boring. That's a measured service. We've got to charge you for this somehow. And the measured service is basically when you're using a cloud, you need to know how much you've consumed. You need to know what rate you're burning at so that you can manage your expenses. So if there's anyone from finance in the room, firstly, I'm sorry. Secondly, it is a key component of any cloud provision because it's a cost. And when you combine on demand, rapid elasticity, you need the measured service to make sure you don't get a bill at the end of the first month, which will sink your budget for the rest of the year. Yes, that has happened. Not in my cloud. Right, so the service models. Now we've talked about what we can do with cloud, what defines a cloud. There are three main service models, which have been defined again in this NIST paper. Gartner have come out and they've tried to say there's an iPaaS and an ePaaS and different, twists and flavors, very much marketing terms. We look at the foundation, we've got three basic models. Who's familiar with these three models? Just raise your hand. Good, we've got quite a few people and a few people who don't. So, IS, who wants to give me an example of an IS service? Just yell it out. There were a lot of hands a minute ago. Right, so infrastructure as a service. So if you want a server, a generic server, you will get a generic server. Usually a virtual machine. You can get what we call a bare metal instance, which has no operating system or anything on it. But the usual deployment is we're looking at storage, network, processing, the CPU of that machine, fundamental resources to deploy and run arbitrary software. And what we're talking about here is the equivalent of a virtual machine that you can load software onto. You can log into it using RDP for the Windows desktop or SSH if you've got a Linux instance. You can run your commands. You can install a database on it. You can install a web server on it. You can configure the network. You can put firewalls in front of it. It's the really low-level stuff. Where this is nice is that rapid elasticity in the scaling, so that if you're doing something and you need more compute resources, your web server's overloaded, you want to add another one to the cluster, that rapid elasticity, the self-service, means that your operations team can just say, put another server of this build into that pool, cluster builds up, you've got more capacity. When the peak of that usage has passed, take it out of the pool, your storage goes down. You want to grow the storage, just resize that disk and add it. So these are typical day-to-day IT operations that we've been doing since the 80s. They've just been modernized to be a lot easier and a lot more self-service. I said database earlier. What's a PaaS service? Anyone got any ideas? Yes? No. Good try though. Yes? Yep. So create and use isn't quite the use case because we created our IS, we created and used our virtual machine. There was another hand down the back. Yes? Sorry? Dynamics. I would say yes, but I don't know that well, so it's somewhere between PaaS and SaaS. Now, the differentiator is platform as a service gives you services and tools, not infrastructure. You don't need to worry about the infrastructure in platform as a service. Now, Oracle is a database company. We have a 40-year-old database. It was one of the first relational databases on the market. It has capabilities which are very broad and deep. We spent a lot of time and money researching and developing it. When you wanted to install a database on your infrastructure, there was an arduous process that you go through. Back in the old days, you'd be putting floppy disks in and running ACOL and setup or whatever. In modern days, Yum installed, you've got all these scripts which set up the database software, configure it. It is still a bit of a manual task. What a PaaS service does is it says, I want a database, give me a database of 4 CPUs and 2 terabytes of storage. You click a button, that database comes up. What if I want an integration platform? So I'm trying to send messages between 2 software components. Again, a PaaS offering will give you that integration layer, and you don't need to worry about the operating system it's running on, or the virtual machine, or the hardware, or any of that. The platform is taken care of for you. What about AI and analytics? Again, you can put a virtual machine on, install your database on that virtual machine, install Ruby or Python, install your Keras or your PyTorch ML libraries, do all of this like joining of the dots together. You can build an AI system that way, or you can just say, give me an analytics engine. Give me an instance of, in Oracle, it's Oak, Oracle Analytics Cloud. Google has their own analytics, Microsoft have their own analytics, and then you just don't worry about half of the job. It's really good. SaaS, we're all familiar with because we've all used it. Who wants to give an example of a SaaS service? I have no idea what that is, so I can't say whether it's true or not. So, Gmail's a good example. I was going to go with Facebook. It's software as a service. It meets the definition. Consumer uses software deployed by the managed service, cloud provider. Consumer has limited ability to configure the application being hosted. How much can you change your Google experience? Light mode, dark mode, that's about it. I know I'm going to get corrected shortly. But if you say, look, I want to have Google and I want to change the branding on the top, not quite, not so much. If you want to change the way that search algorithm works, if you want to change the way PageRank algorithm works, you can't, because Google have done that hard work for you. You just want to consume the service. Other examples of SaaS software are things like ERP, so enterprise resource planning, how you manage your pay and leave. If you want to apply for a day off, you can use SaaS software running in the cloud to manage all of that for you. You're not worrying about the database and the analytics layer. The software provider's done that for you. You're not worrying about the infrastructure. So you can see as we go along from left to right, we're getting less work for ourselves, more functionality provided by that cloud provider. All right. Any questions so far? Cool. So deployment models. Where is the cloud? Where does it sit? We've got three main ones which are the standards. There's also hybrid cloud. Hybrid cloud is just a mix of the two foundational ones. Private cloud, it lives within your data center. Public cloud, it lives in the public. Facebook and the SaaS applications like Google, public cloud. Private cloud is something where you have strict requirements for usually security, so you want to deploy that cloud within your data center and allow nobody else access to it. No internet access, only get to it from your local network. That is still cloud. Why? Because you can have end users within your organization saying, I want another virtual machine. I want to scale up my cluster. It's very popular with development organizations. So as a developer, the bane of my existence in a number of organizations was getting a server that I could test my code on at production scale. It was very difficult because we had contention for these resources. In a cloud world, I can just say, spin up a database over here, spin up an application server over here. I've got that all scripted, so it takes a matter of minutes to do that. And I've taken so much work off the operations team because I've automated it using cloud technologies. And when I'm done with it, I just destroy that entire stack. It goes back into the pool of resources, even though it's still running in the data center. Some cloud providers do have a version of their own cloud that they can distribute. Not all cloud providers do. That's okay. Some hardware providers have their own private clouds. Some organizations build their own private clouds. So they will go out and they'll get the tooling and they will do an incredible amount of work to automate the provisioning of hardware and software, to monitor it, to run the operations, to have someone in the machine room so when a hard drive fails, they're pulling it out of the rack and plugging in a new one in and rebuilding the RAID arrays and all of that stuff that most of us don't really want to worry about. Public cloud, that's taken care of entirely by the cloud provider. Where is it? You don't really want to know. You don't need to know. You're trusting the cloud provider that their facilities are secure, that they have enough. I did actually have a customer once ask me when I was giving an introduction to our cloud, how much diesel do you have in your backup generators in your data center? And I said, more than you. And that was the only answer that they needed to hear. Because again, you're trusting that cloud provider to rely to provide the service. You'll have a service level agreement. If it goes down for more than a minute a month, then you get money back or whatever, depending on the service and the provider. But you're really handing over control of your physical infrastructure to your cloud provider, which is why security, a lot of people are a little bit anxious about. And the hybrid cloud, that's just a mix of the two. So you can have part of your cloud on-prem, and then when you exceed that capacity, Black Friday sales, for example, you start deploying your services into a public cloud instance. Now, if your cloud provider has done their job properly, they will have the same interface, the same tooling, the same services available in your private cloud as in the public cloud. So that transition will become seamless. Someone give me another use case for that. Why would you want to have a second site which is going to be the same as your primary site that you can get to sometimes? Yes? Redundancy. That's the answer. So disaster recovery. Who's had a fire in their data center recently? No one. You think that doesn't happen. Do you know how many fires have been in Oracle data centers since we've been running a cloud for about 7 years? None. Do you know how many fires I've had in customer data centers since I've been at Oracle? 3. I have known 3 customers who have come to us and said, oh my God, we need cloud. We need to move our databases. Well, okay, what's happened? Our data center caught fire. It does happen. It's more common than you'd like to think. And in that case, and it could be power failure, lightning strikes, there's any number of things that can go wrong in a data center. You need to start running your DR somewhere. Cloud is an ideal case for it. If you have to learn a new set of tooling and you have to learn a new set of skills and procedures to run this in your secondary provider, that's no good. And that's where the hybrid cloud model really comes to shine, so that you can take your existing platform, databases, applications, analytics layer, shunt it up to the cloud. That might be in Sydney, it might be in Melbourne, it might be in Singapore. We don't really know. We have certainty where we're moving that to. We don't really care other than data security, than governance, because we want somewhere to run our systems in the event of a disaster. Okay. If you plan for this, it's not a drama. It's really not. If you plan for it and you practice it, it is a very straightforward procedure, and it's an excellent safety net. Any questions before we move on to the cloud benefits? Cool. So agility. Remember, we had that rapid self-service. You don't need to involve anyone else in your cloud decisions. You just get onto the console, I need a new virtual machine. I need a new database. This database is too small, I'll scale it up. This enables more productive staff. This enables more responsive environments, so that if you do have a performance issue in an environment, or you come across a bug or something is not working quite the way it should, you can get a test environment stood up really quickly. You can do your debugging. You're not always going to need that, so you can turn it down, turn it off if you don't need it. But the ability to spin up an environment quickly makes you more productive. The cost is lower in cloud for certain values of lower. If you've got an old farm of equipment sitting in the basement that you're happy ticking away on, cloud is an investment. But if you want to have a refresh of that hardware, you're often looking at hundreds of thousands, if not millions of dollars for a large organization. That's a chunk of money that they need to put forward. This is why we have finance departments. If you want to stand that up in cloud, you're paying per second. That's a really good way to save money. So if you're not using something, you're not paying for it at all. And if you don't need it, you don't have mothballed equipment sitting in your basement gathering dust that you've invested in. Cloud providers also get economies of scale. We buy a lot more computers than you ever will. I guarantee it. I won't ask Google's server count. It's a lot. But I know personally, I've seen inventories of what we've got in our cloud centers, and it is a phenomenal number of cores. We will have occasionally government departments saying, oh, we've got petabytes of data, and we're like, okay, we've got exabytes. There's this. It's not a one-upmanship, but the scale, when we say hyperscale cloud providers, it's a lot. We did quite well through COVID in terms of hardware supply, because we had so much already on hand, and we had so much in the pipeline ready to be delivered to us to expand. And again, it's an insurance policy. It's the amortization of that cost across an entire pool that allows us to provide the security of the pool of resources. Economies of scale, better procurement, cheaper. Operational focus. This is a really important one for government. Who enjoys swapping over hard drives in the data center? Oh, no, hands went up. Maybe there's someone on the chat who likes that. When you're running IT infrastructure, you are seen as a cost. I'm sorry. That's just the way the federal government, most organizations perceive IT, because they're paying your salary, they're paying you to do a job. It's an essential job, but it's a cost. It is not delivering the end user service. We'll have people from the tax office in here maybe. Your service is processing tax returns prosecuting tax cheats, finding tax fraud. The service that you're offering isn't someone swapping hard drives over when they fail. The service that you're offering isn't tying together two networks and making sure that they can securely communicate. The service you're offering is that tax service. Likewise for all the other government departments. So there's a philosophy in government that governments should only do what governments need to do. The rest should be handled by the public sector. I won't get into the arguments about philosophies and political leanings, but a lot of organizations, or most organizations, specialize on what they like to do. What does Tesla do? They build batteries in cars. Okay. What does Toyota do? They build batteries in cars. Well, they build cars and they buy their batteries from someone else. So these companies like to specialize on a single purpose. Federal government is no different. The less you need to do to maintain your stack, the more government work you're doing. Now, there will always be a need to manage the infrastructure and the environment. The operational focus means that you're moving higher and higher up that stack. So if you're in here from a data and analytics team, you don't want to be swapping over hard drives. You don't want to be tying together networks and all the rest of that. You would like to focus on that analytics. The users of the service who actually want to get these reports and charts and trend lines and AI inferences, they don't want to be worrying about any of this either, which is why the IT people in the room have a job, because you're providing a platform for them to use, and you get more value the higher up the stack you can focus. As a developer, I'll just say, my operational focus, writing code. I hated having to put in a request for infrastructure to run my code on. So cloud, again, I'm still in IT, I'm still doing very low level stuff, but I can have more empowerment and I can focus on writing code, not trying to find a server, not trying to install a database, not trying to clean up those resources, not justifying the expense and all the rest of the work that goes along with it. Efficiency. Remember that cloud model, how we have access, broad network access? We can automate that. And this is a key foundation of cloud technology. We would not have cloud if we didn't have automated deployment, because that is what gives us the self-service. So all of the deploying of virtual machines, all the standing up of the network drives and connecting to them and all the rest of that software-defined networking, that can all be automated. That leads to greater efficiency. And this flows on not from that first instance of I need a machine, I'm going to deploy it. It's like, well, we've automated one case of that. Can we repeat that? So if you've got a development environment, a test environment, and a production environment, you can automate that with one template. We'll see a little bit later on how we do this. And you can replay that very quickly. So that means that your operations become faster, more efficient, less cost to the taxpayer. Resilience. And again, we talked about that, what happens when your machine room catches fire. You can move it to another location. Cloud providers, some of them will have one location, some of them will have 3 buildings within a 10-kilometer radius. We have, and I can say this hand on heart, we have more data centers around the world than our leading competitors, which is nice. In federal government, how much do you care about that? Not really much, because data sovereignty. You don't want your data to end up on a server in, for example, Saudi Arabia or Israel, where we have data centers. You want it to stay in Australia. So we've got Sydney and Melbourne, which means if Sydney gets hit by an asteroid, all of your data just comes back online in Melbourne because you have DR procedures and you've tested them and you know they work. Yeah, that's a joke. That never happens. It's never as smooth as you'd like it to be, but we give you that capability so that if there is a disaster in your premises, in your machine room, we have 2 separate cities in Australia outside of what we call asteroid radius, being if an asteroid hits Sydney or Melbourne, we've got another city for you, which is completely distinct that you can move your workloads to. If Australia goes offline, we can move you to Singapore. If Singapore goes offline, Frankfurt, Lisbon, all around the world. And again, when you look at this hyperscale nature of cloud providers, you can see really how much more power you have as a whole platform. It's not just somebody else's computer, it's the whole world's extra computers. All right. Any questions before we move on to security? Yep, audience participation time again. Is it better or worse than traditional on-premises security? Sorry, what was that? Better? I like that answer. I also kind of like the wishy-washy answer. Anyone else? Yes. Mm-hmm.
That data where it is.
Yep.
As an aspect of.
Yep. Okay, so we've had a range of answers. Um, that's the real answer. Mistakes were made. So a lot of the anxiety around moving to cloud is, security breaches. That was the main detractor. It's in most cases cheaper. It brings all of these benefits that you can't argue with. They've been proven again and again commercially. We have people in organizations who go through with a fine-tooth comb the expenditure, the efficiency. The adoption of cloud has come from the simple fact that it works. That's how most technology survives. So there's that hype cycle. People get really cool and ChatGPT and all this like blockchain, Bitcoin, and everyone jumps on the bandwagon. And then they see the reality and it kind of will die off a little bit. And then you go through this second incline where people start to realize, okay, well, this is the part that it works for. We won't blindly rush in, but we'll use it where it's appropriate, and it gets broadly adopted. The security problems from the first generation of the cloud came through ignorance in a lot of parts, uncertainty, people not knowing how to secure a cloud service. Cloud services not being secure by default. That was a problem. You'd set up a computer and then you'd have to put in place a firewall to say, okay, don't allow any traffic onto port 80, that's the web server, or don't allow any traffic onto the database server. Okay, so mistakes were made in the first instance, but we're arguably now in a stronger position because we have had to provide the tooling to secure all these services. Otherwise, we simply would not exist. The problems still exist in your own data centers and your on-premise networks. If you have an internet connection into your data center and a mediocre network security team, you're going to get hacked. Right, it's just going to happen. You put a virtual machine on the internet, especially in the cloud, you are going to have people trying to access that virtual machine to see what's on it. It's got a public IP address. They're going to try and brute force their way into it. So we've had to bring in software-defined networking, things like off-box virtualization, where the network layer is abstracted away to the top of rack switches. So there is a separate rack of computers effectively up the top, which are monitoring, encrypting, and managing the traffic flow between virtual machines in that cloud network, because you've got to remember, everyone is sharing that same network. There's nothing stopping a Russian hacker from providing themselves with a virtual machine in the same data center that your cloud provider is operating from. Absolutely nothing. So we need these things, and a lot of the companies have spent an incredible amount of time and money developing them. How much time and money? More than you. Honest answer. So the economies of scale. I work for a company that's got about 150,000 employees. How many federal government departments have that many people in their IT teams? None. Okay, so again, the hyperscale cloud provider, just like economies of scale, they can devote more resources to security development and providing not only things like always-on encryption, so your network traffic is always encrypted, but we're talking about built-in tools, observability and management, so you can see what's going on in your network, you can see what's happening with your resources. That's usually a bit too late. Like in the movies, the hacker scene, oh no, they've hacked the mainframe. That's too late. They already know you're in the mainframe, you've been hacked. The security tooling, however, is how we prevent that. And again, the cloud providers have things like WAFs, load balancers, and API gateways. Who knows what a WAF is? Nervous hand, yes? Kind of like a firewall? Yes. What type of firewall? Web application firewall. So all of these people in this room, 2 people had an idea about what a WAF is. It's a web application firewall. These cost me virtually nothing, and I can deploy one with 2 clicks of my mouse. How would I do that if I was back in the old days of the on-premises network environments? Right? Do a Google search, web application firewalls, what do they mitigate, compare products, test them out, trial. It was an arduous process. For me as a cloud provider, 2 clicks of a mouse button, you've got a web application firewall. I can see all of the things that'll block, put it in front of my application. I've got software-defined networking, so I know that I can use these tools and daisy chain together my network appropriately to secure my infrastructure. It is much easier in cloud, which makes it much easier to make mistakes, but we'll just ignore that conveniently for now. Again, it's not a magic bullet. There is a learning curve. We give you the tooling, we'll give you load balancers and stuff to build your network. If you do it incorrectly, it's going to crash and burn. Sorry, we can't help you with that. which brings us to the next slide, the shared responsibility model. Remember at the start, I said, this is the slide that you need to take away. This is the key one. This is it. On the left hand, we have on-premises, your traditional deployment models. So if you have a data center and you're providing services to your organization as part of an IT org, help desk services, database, analytics platforms, all that dark blue is your responsibility as an organization. So usually the CIO will take responsibility for that. If it fails, the CIO looks for a new job. It's never quite that simple in the public sector, but we're going from the physical structure, the infrastructure, the building, the rooms, the floor tiles, the network cables, the air conditioning, the cooling. We're looking at the actual infrastructure, the racks, the computers, the virtual machines which are deployed on those, the network, how we tie all these together, the WAN, if you're going off to the internet, if you've got a remote office, if you've got a join Sydney office to Melbourne, to Canberra, to Armidale, that's your responsibility. The virtualization layer. So you might be running, who runs VMware? A couple of nods and hands, yep. Virtualization, how you move your virtual machines around, which again, all of these things rely on each other. So you've got to go down that stack. You can't skip any layer on it. When you've got your virtual machine deployed to VMware, well, you've got to manage that OS. What do you need to do to your operating system every 3 months or so? Obviously, no one from security in the room. Update, patch it. You need to do this. If you don't, you'll get hacked. I can't say that legally, but empirically, it's kind of the applications, whether they're applications you've developed or have been provided, all of that you need to take care of. And then we've got the data in those applications and the user access. Who can log into that system? Who can access it? Who can actually use the services? That's all your responsibility. When we look at the IaaS model, that red chunk down the bottom is taken care of by your cloud provider. Hard drive fails, you don't need to worry about it. Cloud provider will take care of it. So we have a technology called object storage, which is basically a bucket that you can dump large files in or small files. If you're doing, say, analytics work, you might have a bunch of data sets that you need to keep around, dump them in the object storage, pull them back when you need them. It's great. In our cloud, it is triple mirrored. You have 3 copies of that data at all times. You don't need to back it up. We've already done that for you. Each one of those copies is on a separate rack of physical infrastructure. So if a rack catches fire, we've got 2 distinct racks that have copies of that data, and we will rebuild it instantly on a third as soon as we notice the failure. That takes a lot of work to set up. It's something we like to take as granted. We just want to take it as a given. Imagine if you never had to worry about backing up the photos on your home PC or your mobile phone. Who backs up their phone to the cloud? A lot of shaking heads. Who's ever lost a phone and missed out on their, photos from years ago? No, you've been lucky. A couple of nods, not too proud to admit it. So we like the cloud providers to provide this extra value, stuff that you get out of the box that you don't need to worry about, for the simple reason that you then spend your time worrying about things higher up the stack, the actual data, the job that you're providing to the public. With the PaaS system, we take care of the operating system as well. So you remember I mentioned database. Well, that database still needs to run on a virtual machine. It still needs an operating system to host that database environment or the database server. It might be Windows, it might be Linux. Hopefully it's Linux, not that I'm biased. Again, that still needs to be patched. It needs to be updated. The platform as a service offerings for databases mean, give me a database. I don't need to install the operating system. I don't need to patch it. I don't need to worry about updating it, keeping it safe from hackers. I still need to maintain the application which accesses it, and I maintain the data in that database. And I also maintain the user access and who is allowed to log on to that. So there is always this layer. And even when we get over to the SaaS, the application's taken care of. You don't need to do anything with Google search or Facebook. They take care of that all for you. You don't keep, if you keep your password written down on a Post-it note stuck to your monitor, you've failed. That's the shared responsibility model, and it is essential to understand that when it comes to cloud. In some cases, clouds have been breached because the cloud provider made a mistake. Yes, that has happened. In most cases, it's been on the provider, usually at that identity and access layer. They haven't locked services down. They haven't used strong passwords. They haven't used, proper techniques and practices to secure their cloud. So we give you all the tooling, but that doesn't mean we will secure everything for you all the time. Any questions about the shared responsibility model? Anything goes wrong, all your fault. And people they do like to play the blame game. We secretly laugh when another cloud provider gets hacked or has a data breach. I know Google guy's got a very good poker face right there. But you see it from time to time, and the reaction is often one of sympathy, because you'll look at the hack or the exploit and you go, wow, these hackers are good. I never would have thought to exploit the system in that way. There is always the possibility. The shared responsibility model doesn't remove the responsibility from either party. What it means is you've got a partnership with your cloud provider. So if you are procuring cloud services, you better make sure it's someone you can trust. In the Q&A test section, if we've got time, I will devote a little bit of time. There was a mention of certifications and audits earlier. Very big conversation, but I'm happy to start that if there are no other questions in the Q&A. Right, but now let's move on to cloud technologies. How do we make this all work? How do we build this? There's an organization called the Cloud Native Computing Foundation. You can go to the website there, cncf.io. Google, have you contributed anything to this? Yeah, they have. Yep. So what do? They make technologies open source, available, and they host them for cloud native companies to make them sustainable, open, interoperable. Project like Kubernetes. Who's used Kubernetes in the room? Anyone? No one. Sorry. So Kubernetes is a container orchestration platform. If you've got a workload which is running, say, a web server with an application which connects to the web server and talks to a database, you don't want to be setting up all those services separately in different environments. You've got a disaster, it happens, you've got to stand that up in Sydney. You want to do a test of that infrastructure on your laptop. How do we do all this? There's a lot of work involved. Containers take a collection of components and they encapsulate it so that you can run it on a laptop, or you can run it in Oracle's cloud, or you can run it in Google's cloud, or you could run it on a server in the basement of your building, and you can just have that independence to move things around really easily. That's a technology which came largely out of cloud. It draws on technologies from back in the dark ages, Solaris zones, and a whole bunch of Unix paradigms which were used to isolate workloads. The Cloud Native Computing Foundation has been set up to make sure that projects like Kubernetes are contributed to the community, they're guided by the community, they're usable by the whole community, so that we don't have what we call vendor lock-in. So that these technologies are ubiquitous and they can go everywhere. Can you imagine if my Android phone couldn't call an iPhone? Right? That's a problem which technology needs to solve. So why would we have in like the pinnacle of IT, the fact that you can run a workload only on one vendor of computer? Like if I could only run my software on a Dell computer and I couldn't run it on a Macintosh or a Lenovo or Samsung, that would be a big problem for us. Same thing applies with cloud. So we have these projects like Kubernetes, Prometheus for monitoring and visualization and dashboards of what's going on in a cloud environment. Istio, which is a service mesh which allows components to talk together. And they are all brought together under this umbrella. They're made publicly accessible. So we have these de facto standards. They're standards within the foundation, but they're de facto standards. They can be adopted by people. They're not mandatory. And the cloud hyperscalers all jump on board because we know it makes it easier for our customers being you. Right. So this is a really nice thing to have in the cloud. Can you use it on premises? A couple of shy nods. Yes, you actually can. So here's a benefit from cloud. The same technologies can run in your data center. And what does that give you? That portability between environments. So if you learn Istio on premises, you can now use Istio in the cloud. You can use it on Google Cloud, AWS, Oracle. It doesn't really matter. So this is another way that cloud is helping the world. So we are developing technologies that we needed to make cloud happen, to make the environments easy to automate, to make it user accessible, to make it really easy to drive. And we then nicely give it back to the rest of the world, preventing vendor lock-in, making it easier for everyone, more cost effective as well. Right. Q&A. Who's got questions? Are there 100 on the chat? Okay, great.
Great. So thank you, Stephen. That's been really good. I've actually learned a few terms and such as well, which is if I can learn things like that, then it's been a brilliant presentation. So are there any questions? Any questions? Right, here we go. This is where I get my
And in heels too.
Just out of curiosity, have you ever worked with Red Bull?
Have I ever worked with Red Bull? Why would you ask? Yes. Not me personally, though. I've consumed Red Bull in the past. Although kids don't get into the habit. I know there's this trope that IT workers drink a lot of caffeine. Does you no good in the long run. 2 cups of coffee a day maximum, you'll live a lot longer. So Oracle has worked with Red Bull in a number of ways. We gave them a lot of money to sponsor their race cars. Just going to say we won both of the World Driver Championships and Constructors Championships for the last 2 years since we started sponsoring them. Nothing to do with Max Verstappen being a freak of nature and Christian Horner and Adrian Newey and all those people. It was all down to the cloud sponsorship. But we do. One of my favorite photos in the world is a picture of the Red Bull driving past a Ferrari, which is on fire and has the AWS logo on the nose. I'm not allowed to say that in public. Please erase it from the transcript. But to be honest, we do work with Formula One teams. We provide cloud computing. We allow them to run simulations of the races ahead of time. We have strategists within the Red Bull racing team who will model the track, the tyres, the conditions, the weather, and they will run thousands upon thousands of simulations in the cloud in the week leading up to the race or the couple of days leading up to the race. When they're done running those simulations, they throw it in the bin, the infrastructure goes away. They don't need to take that infrastructure to the track. We have young drivers. There's a Red Bull Racing Academy. It's an esports academy. They drive in Xbox simulators. We take their telemetry from that Xbox game. We put it into an autonomous data warehouse. We run analytics and we can say, okay, this person was fast. Why? And the analytics engine will say, because they had less speed coming into turn 2 and they were wider and they hit the apex late. And that was the difference between their laps and the others. We can then take that information, give it to the other drivers who are then candidates essentially for Red Bull Racing in the real world and say, if you come into turn 2 a little wider, brake late and hit the apex later, you'll get a better time and then improve their lap times. So we actually do work with Red Bull quite a bit. And we run the paddock application, do some SaaS and marketing and boring stuff like that. But yeah, we do work with the race cars.
So it just goes to show that racing is both machine and person and continual improvement all the time for both.
Yep.
And I did see Mark Webber's car over in Paris once. It was beautiful.
They look different in real life, don't they?
So I'm curious. One of the contentions around cloud that I've encountered is this reliance on a particular service provider.
Mhm.
That is, if, say, an entire department were to go with AWS, and then we no longer have the ability to support on-premises, so people leave and it becomes a ghost team, then you're stuck with AWS.
Monoculture.
Yeah.
Yeah.
And I was curious what your thoughts on that are, because the fear is you get stuck with this cloud provider and now they can increase their rates.
Right. You remember I mentioned Kubernetes a little while ago? Kubernetes is a generic platform which runs in every cloud. Right. So Google has their own Kubernetes environment. We have ours. AWS have theirs. If I containerize an application and I can do it on my laptop, I can then run that container in any cloud provider. That prevents vendor lock-in. So that is the portability of the workloads. If you have an example, databases, they are not all the same. They are not all created equal. You need a database serving your application. You still have portability of that data. You can choose, there's a bit of an effort involved in migrating from one database to another. One cloud provider to another shouldn't be that hard. There's another technology called Terraform, which came out of HashiCorp, and what that does is it codifies your environment. So you can say, I want 3 virtual machines of the following capacity. And on this one, I'm going to use an Ansible playbook, for example, to push a database. And on this one, I'm going to push my web server. You can set up all that tooling. You can script your environments. You can declaratively define them. And when it comes time to change cloud providers, You change your routes, you move your workloads over, your DNS handles routing to the second cloud provider, and away you go. We used to, I'm not sure if we still do, Larry can be a bit cheeky at times. He bought a red Tesla and on the side had painted, "We will cut your AWS bill in half," and parked it out the front of an AWS convention. Because we want...
CSV, so think of like CSV, JSON, a lot of those constructs. So when you do work with your cloud providers and you're building something on Oracle or Google Cloud, try to leverage, we know open source is really good, but then also to open standards. So when you want to move from one cloud to another, you can export some of that content and move it across. And things like, yeah, JSON, CSV, those open standards, build with open standards.
So where are you going to get tripped up? Things like virtual machine images. I mentioned VMware previously. VMware is kind of proprietary, right? What's the solution to that? You move to an open source virtualization layer. Oracle's got one, Red Hat have them. That you can do that, or you can find a cloud provider which provides VMware in your cloud. It's still proprietary. You're still locked into that VMware ecosystem, but you can have a managed service, essentially a PaaS offering of your virtualization layer. So there are ways out of it. We know this as cloud operators. We've seen the anxiety. We don't want to win because we've held you hostage. No one wants that. We want to win because we've got the best technology. We're solving your problems. We're making you more efficient. You love us for it, and then you spend more money because you're freed up to do other things. So a lot of the mindset in the whole Silicon Valley company ecosystem is constant improvement, constant iterative improvement of all of the systems to make life better for everyone. And that's 10:25, so we're right on the break time.
There's two questions.
Two questions.
Yep. And then I will tell you the comments on the Formula One that's come through.
Cool.
So first question. So really quick answers if that's okay.
Yep.
In the cyber world, cloud computing is more reliable in future? ?
I would say yes, because it's a more standardized environment. Now, the thing is, when you're developing your on-prem environment, you have maybe different firewall vendors, you've got different physical infrastructure, you've got different routers, you've got different compute infrastructure. With a hyperscale cloud provider, we have the benefit of knowing every single piece of hardware in our inventory and what has been deployed, and we know the engineering behind it. We have our own monoculture internally in terms of hardware. We can manage it a lot more easily. We also have a much broader attack surface. So we will see the attacks sooner than you. We will analyze them sooner than you. We will put in preventative measures sooner than you. Some of the vendors in the firewall industry will do this with your on-prem systems. With a hyperscale cloud provider with millions of cores all around the world, we do a lot of work to make sure it never reaches your environment first.
Great. And the second question was, how or what particular tech cloud providers can ensure the data security for highly sensitive government departments, for example, defence, intel, etc., is private cloud the only solution?
Okay, so private cloud isn't the only solution. It is, I believe, the best solution. So if you have a private cloud, you can stick it behind your firewall. There is no internet access. It will never get out of that room. We call that air gapping. You can do that with a private cloud installation while still having all of the tooling in that private cloud. So if you want to spin up a PaaS database, 2 clicks of the mouse. You're not putting in floppy disks or CD-ROMs or downloading images. You've still got all the benefits of cloud, but you've got the security air gapped. You can do this in the public cloud. It comes down to a question of trust. A public cloud will never be air gapped from the internet. You have some technologies, we have maximum security zones, for example, in our cloud, which prevent you from ever putting an internet gateway in. So we can put safeguards around it, but you still have always a degree of trust with the cloud provider. And this leads into the IRAP FedRAMP discussions. Private cloud will always be more secure.
Great. Yep. Now, coming back to Formula One, and I haven't been following Formula One for a little while, so this has actually been quite good because I do like Formula One. So some thoughts. Charles Leclerc is always up for a good crash.
He is, thank you.
And there has been one comment that has been withdrawn, but I do remember saying, get rid of Max and put on Perez.
Checo, yeah, everyone loves Checo. I'm sorry, Max just wins too hard. It's not up to me. He's a phenomenal driver, and part of his talent is evident in the tyre wear at the end of the race. He conserves his tyres better than anyone else while still winning. We don't know how he does it.
So on that note, join me.
Yeah, thanks to ACS for having us here today. It's a wonderful opportunity to come and present to everyone today. So really appreciate that. Make sure this works. Cool. So, hi everyone. My name is Ryan Mills, and I'm a lead cloud architect at Google Cloud for our Australian public sector business. One of the things of my roles at Google is to talk or help customers harness the power of data using cloud analytics tools and techniques. Using data and cloud analytics, we help customers reduce costs whilst transforming the ways customers are using and meeting strategic business objectives and outcomes. So Stephen touched very much on the services around cloud and how you use cloud and the IaaS and PaaS. Today, I'm going to look at more broadly a layer above that around analytics and data, and think about your customers and consumers and who are using those platforms and how they want to consume those platforms. So I'm going to look at cloud analytics as a strategic asset in your organization. I've been working in data analytics for over 15 years across different organizations, technical engineering, enterprise architecture, and I've been fortunate enough to be in the position to work across all industries and segments, as well as startups and large enterprise. I've seen firsthand some of the transformational impact analytics can have on organizations. And the flip side to that, I've also seen many of the pitfalls that we run into with some of these platforms. I believe we're at the cusp of a pretty significant shift today, and I want to share with you some of my observations. And I challenge you to think about your analytics platforms in different ways. So at Google, we call this 10x thinking. Let me start by sharing a story. One of the most successful organizations I've worked with, they've attributed tens of millions of dollars to the value of their cloud data and analytics platform. On the surface, there's nothing significant about this organization that distinguishes them from others. They're not the size of Uber, they're not Netflix, they're not a Google, they don't have the largest data engineering team. But looking at the organization a little bit closer, and in particular, the central platforms team, there is one thing I noticed that sets them apart from other organizations. And it's the way they're measuring the success of their data platform or cloud data platform. Instead of focusing on things like how many reports they can run, how many dashboards they have, number of pipelines they're able to deliver to the business, this team measures success on the percentage of people in their organization using the analytics platform. That's it. So one simple metric, how many users do we have consuming this platform? This means they focus on value, because without value, you don't have any users, right? So if no one finds value in your platform, they're not going to use it. In turn, this prioritizes the focus on trust and quality of the data, because who wants to use data they don't trust? They focus on governance and security, because opening up your data means people giving the right access to the data and not giving access to all the data. They focus on skills and data literacy and empowering their business users to do more through things like self-service. And on day one, when a new employee joins, the data platforms are part of the onboarding process. So as a new starter, they basically also learn how to consume the data platform. The team has delivered truly transformational use case, but they've not done it alone. They've done it by focusing on wide-scale adoption. So many organizations have been successful in adopting ad hoc data analytics approaches with, again, spot benefits around particular small kind of ad hoc benefits, but very few have been able to take this to the next level and adopt large-scale data analytics across an entire organization. So why is this the case? If you've used data platforms in the past, or perhaps you've even migrated to the cloud already, I want to challenge your thinking today. And I want you to think about analytics and what that should look like in 2023, 2024, when you start to build your strategic data analytics cloud journey. To illustrate this, I'm going to use a real simple example. I'm going to use the analogy of a mobile phone. So let me take you back to the early 90s. It's hard to believe, but mobile phones were only accessible by 2% of the population. And so, So they were far from discreet, right? They were really expensive. They charged for 24 hours and you could only use them for 30 minutes of talk time. My nieces and nephews actually find it hard to believe that this was the reality just 30 years ago. I also remember when mobile phones became mainstream. So this was my first mobile phone. For those of you too young in the audience, because there's a lot of young faces here, This was a 5110, and like most people, I had a 5110. It makes basically the purpose of this mobile phone was to do two things: make and receive calls and send and receive text messages. That was it. That was the early kind of mobile phone. Oh, sorry, three purposes. It also had the greatest mobile game ever created, so Snake, if you remember this. Fast forward to today, and mobile phones do so much more. In fact, they're integrated into most parts of our life, right? So like if you look at myself, I use it for my house key, I use it for my camera, my credit card. It even tells me that I got a bad sleep last night because I was stressing over this presentation. All mobile phones, and mobile phones are not for the tech savvy, right? So my 70-something mum uses her phone to store recipes and search for recipes and read food blogs. The bottom line is we still call this a mobile phone, but our expectations of the mobile phone have fundamentally changed, and it has been driven by product and technology. We're now seeing similar innovations in data platforms with cloud. They should no longer function to only support reports and dashboards and descriptive and diagnostic analytics. They are not just for IT people or data scientists who have software engineering degrees. What has happened in the past is when organizations have needed new capabilities, they've invested in an ecosystem and they've effectively had to train others in that ecosystem and upskill them in that ecosystem. Often these new ecosystems obviously require specialist skills and they're difficult to integrate. It reminds me kind of when I used to take my phone, my keys, my camera, all of that with me everywhere I'd go. It was very cumbersome. So your data platform in the future or in 2023, 2024 should support your analytics strategy with people and process at the forefront. And that is very important. So think of the users and the people and process up front. This requires us to rethink cloud data analytics platforms and what they should be. And this will enable us to embed analytics into every role, every process, and every application of our organization. So let's break this down. What do we mean by embedding data into every role within our organization? It's going to be hard to scale, obviously, without basic governance or data governance. At Google, we believe in data governance up front. So you build all the data governance into the platform up front to allow your users to consume with very, very safe guardrails. Just like a car, you don't put airbags in after the fact, right? That would be a terrible idea. The safety features get incorporated into a car when you build it, and your data practice and data analytics platform should be no different. Analytics at scale cannot be deployed without that basic data governance. So at Google, we believe in the platform, and it may seem counterintuitive to do this, but good data governance up front actually helps you move faster and scale down the track. So if you do all the right things up front, you then basically get quicker time to market and quicker time to value from a data analytics perspective. Consider your users' capabilities and consider how your user uses and consumes the data. How do they access the data? Democratization of this is key. Not everyone will access data analytics in the same way. And if you're focusing on scale, you're pretty sure that not all your users will know things like Python, Spark, SQL, that sort of stuff. So, and you can't upskill them. That's just not the answer, right? We can't upskill every user in our organization on Spark or Python. You don't want to lock yourself into monolithic and complex ways of analyzing data. And you really want to focus on your user and bring the tools to your user. So think of things like one user might use BI tools and like those reporting. Another user might like the more technical and they might like SQL, or another user might be a data scientist and want things like a notebook, or someone like my mother who just wants a spreadsheet. Dr. Vicky actually made a great point when I was talking to her at the start of this. She's like, I don't care what happens in the background with all that cloud stuff. I've just got my data here in a spreadsheet and I just want to consume it. And that's the user you need to think about. That user that wants to just start consuming the data without understanding all the stuff under the covers. Whatever the use case, all users should be able to access analytics in the way that makes them feel comfortable. That's what will get more adoption, and then that's what will drive more innovation. You want to meet your users where they are with accessible tools they understand that they can gain value from quickly. So a good example, my mum didn't start using her phone to index her recipes and read food blogs and that. She started with a simple search engine and she was searching on her mobile. And over time, she taught herself to do, again, tagging recipes, food blogs, all that sort of stuff. She learned incidentally, and that is what you want your user's journey to be like. They start using sheets, and then over time they can do pivot tables, and then over time they can start to do low code, no code machine learning. Cool. A great example with this is illustrated by machine learning and AI. arguably one of the most disruptive technologies in our time. One of the biggest challenges to adopting machine learning and AI is skills. So we've found at Google with cloud analytics, we're able to 80% of our customers actively use AI and ML and machine learning using things like no-code machine learning deployment. The industry standard for this is 20 to 30%. So it's very, very low. And that's, again, what's going to drive your adoption of the platform. Where other platforms require highly trained data professionals with knowledge of complex programming languages, you need to think about lowering the barrier to entry to allow customers to train and deploy and basically build their own machine learning models with, again, tools they're comfortable with. So if that's in a spreadsheet or a visualization tool, you need to embed those into those products. So let's looking at embedding data into every process. Now, I want to ask you one question. So what is more important? Understanding what happened in your business last month or understanding what is happening in your business right now? And it's a trick question because they're both valuable. So you want to be able, and you're going to use different use cases to look at historical data, and you might want to use different use cases to look at data right now. So if you break down the business process and how they're made up of micro moments or events. So again, for real-time access to data right now, you might use things like streaming analytics to allow you to make decisions on events that have happened right now and efficiently access and transaction. Like a good example would be fraudulent information. You want to know about that right now. And a good example of that is in banking, where your credit card might get frauded, you get notified right then and there. But then flip side to that is you might want to know about your spending, which is a historical thing, and you'll look back through a bunch of information around how you've been spending for the month. Embedding analytics or embedding data into every process means that we're able to make both historical decisions as well as decisions on data that is being created right now. At Google, we've reimagined the data process from learning analysis on the internet with our search history and trends, right? So we've done this previously with Google Search the last 20 years, and we're now building these into our data platforms of the future. We've brought these two worlds together using a single pane of glass. So you're able to write the code once, and then you can decide on the load frequency using near real time or periodic. So finally, let's consider what it means to embed data into your applications. If you think about data-driven decision-making and how the average business user uses it, there's three stages, effectively. This is oversimplifying it, but there's three stages. There's the data, there's the insights, and then there's the actions. We tend to obviously focus a lot on the data and the insights. We very rarely tend to focus on the actual actions. So what about if and usually what we'll do is we'll build the data and insights in one platform and then the actions in another platform, right? What if we're able to build basically all three into one platform, but we pull the friction out of the process and we make the data basically more usable, and your users then will consume that. Infusing analytics into your application brings insights into the application where it takes place, and then your business users can then make decisions based on where it takes place. Cool. So when thinking about building your analytics strategy for 2023 and beyond, I want you to think about how your technology platform can support analytics at scale. And I encourage you to prioritize and the usability of your platform as a first-class concern. So when building platforms on cloud technologies, think about your users and what they're doing and how they're going to consume the data. Cool. I'm going to leave you this last slide, and then I'm going to jump into a demo. But this is one of my favorite images, and it was the inauguration of Pope Benedict in 2005. And we can see there is not a single mobile phone in sight in 2005. If we fast forward 8 years, in 2013, you can see mobile phones became mainstream, and now the entire crowd is lit up by mobile phones. And this is how you need to think of your data journey. You want your entire organization using your data analytics platform. If we could adopt analytics at scale into every role, every process, and every application into your organization, that is a successful data journey. Cool. So I guess why talk about this when I can just show you a quick example? I'm just going to jump over to my laptop. Give me 2 minutes. And I'm just going to share my screen. Cool. So this comes up. Is that not coming up? It's there. Cool. All right. So is it in the but not in the screen.
Did you take control?
I did. I'll try again.
Take control because you take control from here.
Let me
and
try.
here.
And we'll go. If we can't do it.
Go into Teams meeting.
Oh, on the laptop, do I? Okay. I can see if it worked before. Let me just.
Yeah, perfect on virtual. Just go.
It did pop up on the screen before. We might have to flip to the screen. I'll show you this. I'll jump on and do the technical stuff. Why is that not displaying? Is that okay? I should be able to now.
Sorry.
Oh, sorry. I should be able to share now from here. Yeah, cool. Sorry about that. Always love a good technical issue. Wouldn't be a live demonstration without one. Okay, let's share again. And I'll share my entire screen. Hopefully.
Yes.
Voila. Cool.
Yes.
All right. Awesome. So I'll make this a little bit bigger so you can see it. But effectively, and Stephen did a great job, I guess, before about talking about different services. So infrastructure as a service, platform as a service, and software as a service. This particular option is a platform as a service option. So it is called Google BigQuery, and it's a large-scale data analytics platform. So, because I'll use my mouse, that's all. So effectively, I've logged into the platform now, and I just want to do some simple data analytics. So what I'm going to do is I'm going to create a data set. I'm going to create a data set here called ACS Masterclass Demo. And again, we touched on security. We care about security, so we want to deploy our data. We want to deploy it in Sydney or in Melbourne. So in this case, we're going to deploy this particular service into the Sydney region. I'm going to create this data set. So think of a data set like a database. It's already created, sorry. I can now see my masterclass demo here. So now I want to load some data into that particular data set, right? So I'm going to now open this and I'm going to create a table, right? Very, very simple. I'm going to jump in and I'm going to select my source type. So I can upload it from Google Cloud Storage. I can upload it directly. I can create an empty table. I can even create data from AWS S3 or Azure Blob Storage if I wanted to. In this case, I'm just going to upload it from my computer. I'm going to browse to the file I want. In this case, I'm just going to select the CSV file, and I'm going to give my table a simple name. We'll call it table ACS Masterclass. I'm going to set it to automatically detect my schema because I'm not a schema person. I'm not a database person, so I just want it to do it for me. I'm going to click create now, and this is effectively going to go off and create a data set based on that CSV that I uploaded. Cool. So it's now created it, and we can dive into and see our details. So we can see details there. I've got a schema, and just for context, this is the passenger information from the Titanic. So all the passenger information we can see talks about passenger class, name, sex, age, survived, and things like that. I can actually go preview and preview my data, and I can see all my data there. And if I wanted to, because I'm a SQL person, I could come in here and effectively go query, and I could run a simple SQL query. So I'm now going to run a query on this. I'm now going to get my output from my query. I just did a really simple select star from, right? And I can now see my information. Now, this is great if I'm a SQL DBA and I understand databases and things like that. But what about for your users that just want to do visualization and they don't understand this? Well, if that's the case, we can then have a look at that and we can open the data within Looker Studio. So like a visualization tool now. So now I'm getting direct access to the data from a visualization tool, and I can start to build visualizations using charts and things that I'm familiar with in that sense. And here we go. It's loading up now. We can see some data there. So there's our data. I can add another chart, for instance. I can add a pie chart. Drag that in there. Cool. I'll pop that down here. And this is going to show me some information. In this case, I want to understand the data of, let's say, age bracket. So now I can see all the age brackets in a nice pie chart. So again, allowing your SQL DBAs to start to access data in a way they feel comfortable with, running SQL queries and stuff like that, but then allow your business users starting to access data in a form they feel comfortable with using business intelligence. This is cool and it's great for my business users, but what happens if I wanted to, for instance, start to look at the data in like a notebook and do some more machine learning and things like that? Well, I could explore the data with a notebook now. So now I've got a really, really deep technical person who understands Python and coding and machine learning, and they're able to access the data within a notebook and start to run machine learning models within the notebook. But you know what? This is way, way, way too comfortable. And someone like my mother, she just wants to access some data in a spreadsheet. So we're going to jump into Sheets. I'm going to create a new sheet. And then I'm going to load the data in Sheets because that's what I feel comfortable with. So I'm going to connect to BigQuery now. I'm going to look at my masterclass that I created, and we can see our table here. And I'm going to connect to my table. So now, as a simple business user who just understands spreadsheets, I can start to consume my data in a way that I'm comfortable with and a way that I'm familiar with. So I can build pivot tables in here, and I can start to run machine learning natively within Sheets, for instance. So yeah, really, really simple way across, again, different use cases for different parts of the business to all consume the data in a way they feel comfortable with. This is really cool. It kind of gives us that flexibility. But what happens when my data grows or I want to start to do real analytics? I'm almost done. I'll answer your question. Imagine we have a data set that's so big and I want to start to analyze that. So I'm going to cheat and just show you an example of a test data set that I have here. So for reference, the data set we updated previously was only 89 kilobits, and it only had 891 rows. What happens when my data grows? What happens when I've got a data set that's a table that's 6.7 terabytes and 100 billion rows, and I want to start to query that in real time? Well, this is the beauty of cloud and platform as a service. It just scales to whatever you need. So I'm going to cheat and use a query that I created earlier, do the old cooking thing. Here's a simple query, really, really bad query. I'm effectively going to do a select star on that 100 billion rows of data, and I'm going to do 3 regular expressions, right? You probably never do this in production, but we'll do it anyway. I'm going to not cheat, and I'm actually going to turn off caching because we can cache results if you've got a bunch of users all hitting the same data. I'm going to turn that off. I'll hide that. I'm going to save that now, and now I'm going to run the query. So you can see up the top here, it actually says this query will process 4.06 terabytes of data when complete. So it's telling us how much data it's going to process. So if we now run this query, hopefully the demo gods are kind. So this is going to now start to kick off. You can see our queries running up the top there. It's running through. This usually takes, let's say, 40 seconds to a minute 20. But what this is doing in the back end, it's taking all that large amount of data we have, it's pulling it across a high-speed network, and then it's scaling it out to thousands and thousands of compute nodes to basically process this data for you. Some of our largest compute nodes end up being the size of like 60,000 nodes. So yeah, that's, I guess, the benefit of cloud around scaling. So that is a really good example because it actually completed in 20 seconds. So we just processed 4 terabytes of data with 100 billion rows in 20 seconds of data. And that is a good example of why you would use cloud, because on-prem you just can't scale like this, whereas in cloud we can. And we have, again, example customers that we've taken data sets and they've been running them on-prem and they've been taking 2 or 3 hours to run using their traditional systems. They pull them over and run them in a solution like this, and they're able to kind of run in 20 or 30 seconds. And that's where you start to get that real-time, real live analytics from that standpoint. That's literally it. So happy to jump to Q&A now. I will stop sharing my screen. Oh, and then
Thanks, Ryan.
jump back over here.
So we've got plenty of time for questions, and it's really quite good. You know, you talk about the mobile phone. I remember my parents had their first mobile phone, which was a brick. It was the size of the battery, which was like this big, and they had a basket to carry the phone in. So how it has changed. Cool. So do we have any questions for Ryan? This one here. Great.
This is just a curiosity question. In that last scene, you had one of the activities that you did was you imported your data set into Excel.
Yep.
Is that read only, or can you write in Excel and
So
then that
by
changes?
default, it is read only.
I see.
But you could effectively, we have customers where we've set up like a script, or think of like a macro, where you can do download, upload, and push. So yeah, out of the box, it's read only, but you can effectively set up like a macro that allows you to make it push data.
Sweet. I have another question, but I'll leave it for someone else if they want to go first.
So with a lot of Google's services, such as Google Docs, which is all real time, I guess.
Yep.
Does that also implement that cloud technology? And how do you combat kind of, multiple users writing into the same piece of data at once?
Yeah.
If it's within the cloud?
Yeah, cool. So that's a great question. So yes, and I guess that's the thing that differentiates us from some of our competitors is a lot of the Google services that we've built into cloud, we've built for Google. So without going into like deep diving into it, but effectively Google's journey, we started with search, right? And search was like 10,000 users, 100,000. Before we know it, it's like 100 million. And for context, we service about 2 billion active concurrent users today on the platform. And what we realized is, hey, we've built all this cool stuff internally, like docs and all that stuff. Customers actually could gain value from this. So we then have started to release a lot of our internal platforms we use into public. And that's what, again, customers are getting the value from a Google perspective. To answer your question specifically, yes, data lineage is a massive part of it. So you need to, when you're using things like BigQuery, it has data lineage inbuilt. So you can then start to see who's done inserts, who's done edits, who's done that sort of stuff. And that would be part of your data governance journey. I talked obviously about that particular customer and their journey. They built all that data governance in upfront around understanding data lineage and understanding who's accessing the data and the permissions and the edits. So then that way, someone like yourself can just jump in and start consuming, and you don't have to worry about that. But if we need an audit or a log, we have logs and audits and all of that from that standpoint. So.
Thanks for the talk, Ryan and Steve, before then. My next question is around, I guess, protecting the customer almost from themselves sometimes.
Yeah.
And that is I know there are nightmare stories. Steve brought this up of a customer using their entire yearly budget in a month.
Yep.
What protections exist that Google or Oracle have provided against that?
So cloud or cost governance is a big one. So there's two ways to look at protecting. There's protection from security, where you want to help customers inadvertently make a mistake. And a great example of this is when we've seen customers open buckets to the public, and customers' data obviously gets leaked, and we never like to see that. So on the security side, Google tries to build in what's called invisible security controls. So stuff that you don't have to worry about, and they're just on by default. And a good example of that is public access to buckets is not on by default. You've got to turn that on, right? So public access to any storage buckets is on by default. You cannot get access to it. We do things like by default, we encrypt your data in flight and at rest and in transit. So again, trying to build those security controls in, because we understand that our users don't necessarily understand these technologies as well as Google does. So we build a lot of those security controls in invisibly and just enable them by default. To be perfectly frank, we don't want to see a government agency on the front page of the paper, because it reflects just as bad on the government agency as it does Google. And this is where I guess Steve touched on shared responsibility model before. Google takes a shared fate model where we have the same fate. So if you get breached, we get breached and we look bad, right? So how do we work together? Around, again, the cost control, you can do things like you can limit APIs, you can limit query size. So a great example is I did a massive query then, but I could set up a small little sandpit that only allowed you to query 10 million rows of data and things like that. So you very much got to set in user-based access controls that limit your users to doing things that are just too. And another simple example of that is you don't want your users going in and spinning up the largest compute size they can. So you effectively just limit what compute they have access to deploy, and building those controls up front, so then you don't have to worry and get bill shock kind of after that.
Thank you.
So Ryan, I guess that's actually quite a good question. And I guess this is the beauty of these series of masterclasses, just getting that understanding so you know what questions you need to ask. Because I guess that when you're starting to talk with potential vendors and procurement, you need to ask the right questions so you can interrogate those issues like ongoing costs and how to actually manage those as a risk, isn't it? So
yeah, 100%. Cost governance is a huge part of kind of what we work with customers. I've got a number of government customers that I'm working at the moment around doing things like chargeback. So again, a lot of you will go out to build and be IT people. You'll build an IT platform, and then if you start to get your business users consuming in a user self-service way, how do you then provide like chargeback and cost governance to them? So it is a big part of what we do. So when a business unit, so like imagine you're in IT and governance, and the legal team or the HR team are running a service, you effectively charge them for that service. So you're passing the cost on to them.
it's like a user pay.
100%.
Yep.
Yeah, great example.
Okay, so there's one question, or there's one question, well, there's a couple of questions here online.
Yep.
I'll ask one and then I'll go back to the room. So is it possible to make a UI for inserting into Google Cloud the data sets, say like a simple web form that can search values for updating, etc.?
The short answer to that question is yes. Yeah, and like anything's possible with that sort of stuff. You could build a simple microservice that's got a web page that runs in a container service. Yeah, the world is, and I guess that is the advantage of cloud. The world is really your oyster with what you can build. Stuff that historically a startup couldn't potentially do, because to spend hundreds of thousands of dollars on infrastructure and stuff like that, they just didn't have the budget. Cloud really allows you to do that because you can spin up stuff very easily and not have to pay hundreds of thousands of dollars. But yeah, if there's like a good example, and again, you saw that before, Firebase, right? Firebase is super simple to do, like mobile app deployment. We've got another one called AppSheet, which again allows you to do really simple data kind of mobile app deployment and stuff like that. So yeah.
What is your future outlook on cloud tech? And will we one day see, devices that doesn't really have anything in there and just query the cloud for computing power and just get the results?
Yeah, so like obviously I can't speak on behalf of Google because I don't know what their outlook is, but I think, yeah, you're right. Eventually we're becoming much more developer centric now, and much more business user centric now. So I think you'll see a lot more SaaS offerings where businesses just can start to consume SaaS services because they're much easier and quicker to consume, as well as also developers having direct access to spin stuff up much quickly from that standpoint. Eventually, and this is again the Google approach where we've always just tried to provide APIs that developers can just hit APIs and they don't have to worry about all the stuff in the background to be able to deploy their app and then kind of do their application building.
Great. Are there any other questions in the room?
I'm surprised there hasn't been any Google questions. Not always Google questions.
Google doesn't have a F1 team.
But yeah, I can bring my dog to work though. And there are slides and beanbags.
What was the business that you started?
So like, well, the original business was search. So effectively search.
Sorry, when you start the presentation.
Okay. So without going into too much detail, because I've been told I'm not allowed to give names of businesses, but it's a large retail chain based here in Australia that might have a tinge of green in their logo. I'm sure you can figure out who's. And to be fair, they've publicly had on-stage sessions with us talking about how they've done data analytics at Google. So if you quickly Google, you'll find who it is.
Any other questions? While people are thinking at questions, I think one of in your example there, that when you started looking at, like I saw the map there and I'm going, oh, I remember when I was down in Tasmania and how they were starting to use data analytics to predict traffic flows and the difference between holidays and non-holidays.
Yep. Because
Tasmania, where I was in Hobart, only has 3 ways into the city, from across the river, from the south and from the north. And they were saying there's a 7% difference in the traffic between holidays and non-holidays, school holidays. And that 7% made such a big difference to people's attitude to the traffic management.
Yep.
But then, it's so that's that example of how you use the data in the past, but then how you actually monitor it as you're making changes with traffic management techniques and whatever else. I find this stuff interesting. So again, it's more the end user interesting piece rather than the actual how
Yeah.
do you do it.
I'm going to hang around too, so feel free to come and have a chat after this. More than happy to have a chat.
Okay, final chance for questions. Let me just check if there are any on. Oop, glasses on. Here we go. So, a couple of things. Oh, okay, yeah, okay. Google Chrome sponsors McLaren.
We do, yeah. We do.
My
Yeah,
bad.
we do.
Okay, coming back to a question on Google.
Yep.
From a business and brand point of view, does Google Suite cooperate with most Microsoft Suite things such as Excel, SharePoint, blah, blah, blah?
Yeah.
None of the government departments know, noting some departments only use MS Suite.
Yeah. So the short answer is yes, we obviously do our best. So to do that, Google is a huge contributor to open source, and we've been doing open source before it became cool. We're now trying to push for open standards. So I touched on this earlier around ensuring interoperability using formats that everyone can just pick up and consume, and that's things like CSV, JSON, stuff like that. So when you start to deploy these workloads in cloud, you obviously have that interoperability. The same goes with things like video conferencing. We can now obviously join WebExes from Google Meet and vice versa. So we're trying to obviously integrate those as well. So it doesn't matter what video conferencing platform you're on, everyone can join from, again, a platform that they're familiar with. So yes, we do invest heavily in that and try and push that. We're very big on open standards.
And I guess that kind of flows into the next question, that open standards piece about how you handle the cross integration while still prioritizing the Google Suite.
Yeah. So, and like a good example of that is the product that I showed just before, BigQuery. We understand, again, customers have data in AWS. Someone mentioned AWS before. So what we've done, we've effectively built a BigQuery tenancy in AWS and allowing you to run queries where your data is. So you don't have to specifically pick up and move that data. So that's, again, a feature where we understand customers are going to have all three clouds, if not more, and they're deciding on the cloud on very specific business use cases. So then how do we ensure that no matter what cloud they use, we're able to access and share and process the data?
Okay. Any more questions in the room? Right, I've got one last question online. How does Google approach the characterization of data points for customers and make use of tools like data dictionaries?
From a metadata tagging or data cataloging perspective, or?
Don't know.
Okay.
Maybe both.
Yeah. Okay. So I guess that would be part of your data pipeline. So looking, obviously, if you've got a bunch of different data pipelines, you would want to pull them in, and as part of pulling those in, you would do things like tagging to do data lineage and things like that. You can set up automated tagging as part of those processes. One of the cool things now that we're starting to see the emergence of with some of these large language models is things like auto tagging. So again, a lot of the users aren't the best at tagging their data and actually providing insight as to what their data is. So again, if we can automate that process so the user doesn't have to, using machine learning and things like that, yeah, we can do that as well.
Great. I'm just double checking. I think I've missed a question. Here we go. So would a simple UI service be directly developed using a Google application, or would it be done using an API?
You could do either.
Okay.
So yeah, either you could directly hit an API and build that way, or you could build your own UX service and then allow your users to consume your UX service and upload from there. So yeah, you can do either. Again, work with your users. Some users like GUI, some users like API, some users like command line. We can do all of them. So yeah.
Great. Well, I think we have now exhausted all the questions. So one more.
I found it interesting that you mentioned Google produces a lot of things in-house and for internal use,
Yep.
and then release them publicly after they realize there's a market for it.
Yep.
I wanted to ask, I guess, why does it do that? Why develop something in-house when there are already existing solutions? I think it goes as far as to your own version control, your own Excel version, like your own Word,
Yeah,
et cetera, et cetera.
So yeah, look, it's a great question, and the main driver of why we do stuff in-house is because people just don't see the volume of data Google sees. So like if you've worked in government systems and things like that, which I have, is you're building scale where you might have 1,000 users or 10,000 users. When Google builds an application, from day one, we expect we're going to have 10 million users at a minimum. And then we scale from there. So when you're starting to look at things where you need notifications for 100, like let's say 2 billion users, and you're doing hundreds of millions of push notifications a second, a lot of the traditional open source tooling in that might not necessarily meet those requirements. And a great example, Google internally, we worked on the Hadoop project, and we originally used it for some of our data stuff, but then we found that we were hitting some limitations around that. So then we expanded on that and then started to build that capability out. We then do, again, open source a lot of that. So a great example is Kubernetes. Kubernetes is a container system, and Google's been running on containers since our adoption back in 2000. And we saw the value in containers, but a great example, I guess, is, I think, and again, don't quote me on this, but the largest Kubernetes cluster you can run, I think, about 10,000 nodes. We have clusters upwards of about 80,000 nodes, right? So we effectively, anything we do build in-house, and a great example of that is our Kubernetes stack in-house that we put features into, we then roll them into our open source offerings and things like that. But yeah, the reason why I guess we've done a lot of that internal development is for the Google business and to build those Google services. And then if we see value, then we provide that back to the open source business and stuff like that. So a lot of the technologies we're building ourselves for the first time, just because no one else has ever seen this challenge before. And that's why we do it. I can use a really good example. We started doing machine learning back in 2002, right? And we used machine learning with search, and we've been doing it for a long time. The first machine learning model we were looking at, the largest open public data set, I think, was about 1 million rows of data. And our first data set internally was 100 million rows. So all the traditional methods outside of like Google with machine learning, just they'd never seen that data. And then when we tried to use those tools, we were running into problems. So that's where Google built TensorFlow, right? So we built this internal software for machine learning, a framework called TensorFlow, to use Google scale and build for Google. And then we saw value in it, and then we open sourced TensorFlow, right? Fast forward that, we then, obviously with machine learning, we started to run into limitations and constraints around CPUs and GPUs. So then we built our own hardware accelerator chip called a TPU, or a TensorFlow processing chip. And again, that was just because we were hitting limitations of those that no one else had ever seen before. So then we built our own. And then, yeah, if we see